I had nothing to do with it.
We have Jill Tarter on the phone. I don't know if you're going to be able to hear her. Okay. Before we get started, I must say I got a fortune cookie, as many of you did, and the fortune cookie said, "You will accomplish great things with the help of good friends." And that reminded me that I forgot to acknowledge the scientific organizing committee who made all of this possible. We've got them all here now. Alan Boss, Steve is here somewhere, I'm sure. Yes, Steve, okay. Dawn Gelino was unable to join us. Joe Lazio, Karen O'Neill, Martine, and Jason. So thank you very much. They really helped us today. And then we'll turn this over to Tim Kellermann.
By the way, Catherine got a fortune cookie that's actually even more directly related to the goal of this meeting.
It's spectacular. It says, "Good news will come to you from far, far away." It's really personal. I might CC you.
No trouble. That sounds more encouraging than what I was about to say. As I said yesterday, since Project Osmo some 60 years ago, our sensitivity to detect the kind of signals that we're familiar with here on the Earth, depending on how you do the calculation, is increased by, I don't know, 10 million or 100 million. But the number of detected alien civilizations hasn't increased, and it's still zero. And so, that raises the obvious question: Are we doing something wrong? And if so, what should we do? What should we do differently? As I said in my talk yesterday, there have been lots of international meetings, but I think relatively little actual international collaborations. We're familiar with international collaborations in astronomy, even in space science, and even with the former Soviet Union and now with Russia. I'm not aware of any real collaborations between, say, U.S. and Russians, which are the only others that have really done a lot of SETI work. And so I wonder, are we looking with too narrow a vision, or are we just looking for advanced civilizations of the kind, just slightly advanced or moderately advanced from what we are? Or as Chris Impey talked last night, can we really comprehend what to look for, or what people might be doing who are thousands, tens of thousands, hundreds of thousands of years more advanced than we are?
Billions.
Well, that gets into other issues. And should we be looking at, in other areas than electromagnetic signals? Things like we're familiar with Dyson spheres or actual probes that other civilizations may have sent to our solar system. But the microwave studies are continuing, and if so, what's the optimum frequencies to use? Where should we look? I think most of the work has been on relatively nearby stars, assuming just some modest extrapolation of our own capabilities. But that assumes that the technology is only somewhat more advanced than ours. If you think of a civilization that's, Kardashev's type 2 or type 3 civilizations, we should be looking perhaps at other galaxies or even distant parts of the universe. Is there anything to learn from our continued failures? And the other question to think about is, how should future SETI work be organized? I think historically, as we know, most scientific discoveries in astronomy, at least, have come about from work by either individuals or small groups. Because have we exhausted that simple approach? Is it going to take a major effort at the level of Apollo, or, for example, or Cyclops to make significant progress? Or should there be more broad-based support for for individual PIs? Are there sufficient private resources to make significant progress in SETI. Or is there sufficient will in the private community to make significant progress? Should there be more government support, either from NASA or the NSF? Say at the level of ALMA, with ELTs, we're talking 10 to the 9, a few times 10 to the $9. What are the advantages and disadvantages of support by NASA and the NSF? I think we know the two agencies, we know their pros and cons, they're different. So we put together a panel of experts who I think have agreed to address some of these questions that I have up there. And so we'll start with a short presentation from each person on the panel who want to say something, be followed by questions and comments from the other panel members, and then open to the floor. And so we're going to start with Rebecca, who's going to address. Jill's not here. Jill, can you bring up Rebecca's talk? She's going to address mostly questions of international collaboration, particularly with regard to the former Soviet Union and Russia.
You know what? We can work with this. Okay. Hi. So Ken asked me to speak for 10 minutes or so to start off the panel. I am a historian, so I'm not going to be able to speak very much to the future of SETI, but I can very much tell you what happened in the past. I'm also representing, of course, the only humanities person, I think that's fair to say, on this panel. So I thought maybe we'd start off by reviewing what humanities people have said thus far at this conference. We had Steve, who emphasized the impact and the importance of the humanities in general to astrobiology and SETI, especially in helping to prepare to navigate possible future scenarios. We had Kelly, who discussed the role of philosophy in framing our scientific perspectives and definitions. Then there was Catherine with the anthropology-style approach to ethics and trouble that SETI and astrobiology may face. And then I'm going to take a slightly different approach and address the history of astrobiology and SETI, more specifically SETI for this panel, so that we can better understand the mistakes and successes, and then these people can move forward with that information and figure out what they want to do next. So even though I'm a SETI historian, the question that preoccupies me is a lot closer to Earth. I'm very interested in the SETI scientists themselves, particularly in the 60s and 70s, those in the Soviet Union and the United States. And in particular, the question that fascinates me is, why was it primarily the Soviet Union and the United States in the 60s and early 70s who were so fascinated by SETI? And so I also want to know what came of that effort. And so I'm going to touch upon a little bit of these thoughts in this brief 10 minutes. Before I get too deep into things, I think it's worth mentioning that, like Ken briefly mentioned in his first talk, SETI used to be called SETI with a C. I think they also just said SETI. I don't think they said SETI with a C. But that stood for Communication with Extraterrestrial Intelligence. And I think that is very revealing of what the early SETI pioneers thought they were doing. They were very much not only preoccupied with the idea of finding extraterrestrial intelligence, but also the whole idea of communicating with them and how we might solve that problem of communicating with life that is immensely different, potentially from our own. Another reason why SETI with a C was very popular in the 60s and early 70s was because of the kind of serendipitous coincidences that came along with the phrase. The first being that, of course, the first star that Frank Drake observed in his Project Ozma was Tau Ceti with a C. In addition, Ken mentioned, and so did Catherine in her talk, John Lilly studied cetaceans. And this was of great interest to the early SETI pioneers. In fact, in 1961, at the first ever SETI conference here in Green Bank, John Lilly was in attendance. For those of you who don't know very much about him, he studied dolphin communication and attempted to essentially solve dolphin language. And so the attendees of the Green Bank SETI conference, it very much did not pass their awareness of the coincidences between what they were doing, trying to communicate with intelligent non-human life forms, and what Lilly and his laboratory were doing. And as a result, they decided to dub themselves, this small group of scientists in 1961, the Order of the Dolphin. And in fact, this caught on for quite some time. This is a letter we have in NRA archives that's addressed actually to Frank, and it says, "Dear Honorary Dolphin." So this is very much something that... Right, so we might be tempted to say, well, that's very silly, and perhaps it is very silly, but at the same time, and there's nothing wrong with being silly, I delight in it. But it very much betrays the mindset of what these men were doing. And to further this idea, I'd like to tell you a little bit about the first Seti conference that was held jointly with the Soviet Union in 1971, called the Conference on Communication with Extraterrestrial Intelligence, and that's the same in Russian down there at the bottom of quotations. So at this conference, it was attended primarily by US and USSR scientists and engineers. In fact, there were only 4 other attendees from different countries, one of whom was actually Francis Crick, the co-discoverer of DNA. And I think that goes to show the interdisciplinary curiosity around this subject. And in fact, he was not the only non-scientist or engineer in attendance. Carl Sagan, who was the organizer on the US side, had the foresight to invite a historian. And that is how William McNeill, a historian, professor of history at the University of Chicago, found himself in the Soviet Union in 1971, surrounded by a bunch of astronomers and engineers who wanted to find extraterrestrials. Now, that may seem rather peculiar to you, but McNeill was a rather deliberate choice. Just a few years earlier, he had published one of the first popular books of world history. Now, that may not seem very unusual to you. World history, global history are words we're all very familiar with nowadays. But in the 1960s, it was a rather novel thing. Up until that point, Western history had been very Eurocentric, very defined by nation states, so you would have a French historian and an English historian. But in the 60s, historians were starting to think, well, what happens when civilizations come into contact with one another? How do they interact with one another, communicate with one another? And so that is where the role of the historian and the role of the SETI scientists overlapped. So McNeill was primarily arguing in his book, which was titled The Rise of the West. We can discuss the implications of that title later. But his argument was that contact and communication between foreign civilizations was the primary driver of human history. In my own work, I take a similar approach. I study the contact and communication between alien civilizations. The alien civilizations in question are the United States and the USSR, highly technological civilizations quite alien to one another. And so I'd like to transition by telling you a small story that I think illustrates this point. Steve in his talk had mentioned false flags, hoaxes in SETI history. I'd like to briefly tell you about one of those that I think also really illustrates how SETI history, even in its failures, has sometimes ended in really fascinating examples of innovation and communication between alien civilizations here on Earth. So I'm sure many of you recognize this man. His name has floated around this conference quite a bit. His name is Nikolai Kardashev. He is a SETI pioneer from the Soviet Union. He published in 1963 this article that was called Transmission of Information by Extraterrestrial Civilizations. Like Ken mentioned in his PowerPoint, the Soviet Union was primarily interested in finding sources of really small angular resolution, thinking that that would indicate artificial nature. And so in this article, Kardashev makes that exact point, that an artificial source would have very small angular dimensions. And so he and his co-worker, Josef Shklovsky, who I'm sure also many of you know, decided to send one of their graduate students, Gennady Sholomitsky, to look for cases of really small angular resolutions that also might happen to have other evidences of artificial nature, such as variability. You have to remember that in the early 1960s, there had not been any evidence of, in the radio, extragalactic variable sources, with the exception of perhaps Cas-A, which was a supernova remnant, which was slowly decreasing over time. And so Gennady Sholomitsky, in his observations of this one source, CTA-102, found intrinsic extragalactic periodic variability. And so he immediately sent out a IAU telegram saying that he had made this discovery, which was potentially groundbreaking, not only in SETI, but in radio astronomy more generally. Unfortunately, he had made these observations on the Pluton Deep Space Communication Complex in Yevpatoria and the Crimea during the height of the space race in the Cold War, and therefore could not publish a lot of the information on his observations. So many radio astronomers, including this guy, actually wrote that, you know what, Sholomitsky's results have not been accepted because we just simply can't verify his results. But it actually was the case that Sholomitsky did discover extragalactic variability in the radio. And so the Soviet Union rushed ahead and they had a press conference at Sternberg Astronomical Institute in Moscow. Pictured here is Sholomitsky, Yosef Shklovsky, and Nikolai Kardashev, looking very happy with themselves. Kardashev mentioned at this press conference that he thought it's possible that this very small variable source might be evidence of extraterrestrial intelligence. And a TASS reporter, for those of you who don't know what TASS is, it was a Soviet state news outlet that published articles via telegram to get it out very quickly. This was before the internet. So Alexander Midler, this reporter, overheard what Kardashev said and quickly published a telegram. For those of you who don't speak Russian, that said at the top, the USSR is signaled by a friendly civilization. And so this was published all over the US and eventually picked up by foreign journalists, who, frankly, were not very positive about that. It's a bit Trumpian, sad. And so that's Sir Bernard Lovell of Jodrell Bank. And of course, Sholomitsky's results were now even more universally panned. First for not revealing the information of their observations, but then additionally for making claims about it being extraterrestrial intelligence. Yosef Shklovsky, a few days later after seeing the international response, quickly put out an editorial in Pravda saying that, well, yes, it is possible that it's extraterrestrial intelligence, but it's very more likely that this is a natural phenomena, and he backtracked a lot of what he said. Nonetheless, it's not that nothing came out of this. You might be tempted to look at CTA-102 and say this is an abject failure and an embarrassment for Soviet scientists. But instead, Kardashev and Sholomitsky pressed ahead, not necessarily thinking that it was extraterrestrial intelligence at this point, because it was quite clear after speaking with their US colleagues who had recently been making observations out in Caltech that it was a quasar, not extraterrestrial intelligence. But they were still very preoccupied with the idea of small angular sources. And so Kardashev and Sholomitsky, along with Leonid Matvienko, published what is considered to be the first ever published article on proposing very long baseline interferometry as a technique. And this paper, along with their continued communication with their colleagues in the US, led this very dashing young Ken Kellermann not trying to embarrass you, Ken. To conduct this a little bit. He's my supervisor. I found this.
Two stars, okay.
So Ken and this group in the Soviet Union ended up conducting the first very long baseline interferometry experiment between the US and the Soviet Union. And these relationships that were formed ended up continuing into the 70s. This is a paper from NRAO's no longer in published newsletter called The Observer, where you see Kardashev and Matvienko have been invited to continue work at NRAO. And these relationships lasted for decades, leading to, I'm sure many of you are familiar with Radio Astron, which was just decommissioned last month. And so Steve said yesterday that the ideas and thoughts that astrobiology and SETI provoke, even if they don't come to fruition, are good thought experiments. And I completely agree with that. But I think you can go even a step further and say that there's documented evidence that there's a positive effect that SETI has on international collaboration, and that it facilitates creative thinking that leads to the development of techniques and international partnerships that they might not otherwise have had. So with that, I think it's a good way to lead off where SETI is going in the future.
Okay. Thank you, Rebecca. Frank, do you have any thoughts, I think you do, about why it's just the Soviet Union and the U.S. that are so involved in SETI?
Well, I think it was clear from what we just heard that their interests were very clear and that they were not underhanded. The people in the USSR who were engaged in SETI, and there was quite a few, and some of them were brilliant. Kardashev was brilliant, Shklovsky was brilliant, and there were several others that were top-notch radio engineers or scientists. They were not of the ilk that were obsessed with showing the superiority of the Soviet Union. They were just true red-blooded, proper scientists who wanted to see some good science done. They knew the Americans were really good at it, and they thought it was a very good thing for them to cooperate with the Americans in SETI projects because they would benefit from our knowledge, and it would allow them to do a good search, and they expected us to do a good search. So there was no politics about it at all. These were good people the whole time, and we worked with them for 2 decades at least. In fact, we worked with them until the Soviet Union collapsed in 1990. And that was interesting. I'm going to tell you a little anecdote. We used to meet with the Russians every 10 years somewhere. One year it was in Tallinn in Estonia, another time it was in Berea in Armenia, which was a Soviet Union country. One year it was in Santa Cruz, California, which I engineered. And on the last meeting was scheduled and took place in the United States, and this was the Santa Cruz meeting I just mentioned. And what happened was I drove down to the San Francisco airport to pick them up and take them to a hotel, which was an interesting experience because we had a contract with the Soviet Union to supply them with spending money as well as free lodging. When we went to the USSR, they did the same to us. And so I took them to a hotel near the airport in San Francisco, and they were dumbfounded. They'd never seen such a wonderful, beautiful place. And then I set them all down, and they were tired. They'd had a hard flight from Moscow, had to change planes. They had to go on Aeroflot, which is a terrible thing. And I said, well, I have some little business to do with you, and then you can get a good night's sleep. Well, the business I had to do was to give them each $200, which was the first segment of the support money we were to give people from the Soviet Union. And I was in charge of all this. So I had a whole pocket full of $20 bills, and I gave each one of them $200. And when I ended, one of them was crying. And I thought, what have I done wrong? Why is he mad? I said, what's the problem? He said, you know what you just did? I said, no. I said, he said, you just gave us each a whole year's salary. Wow. And I thought, oh, wow. And I said, well, I'm glad to hear it, but that's the way it is. It's your money, you spend it any way you want. And of course, they were delighted. Their reaction was not only joy, but from then on during their stay, they saved every penny. The next morning, they went to the nearest 7-Eleven and bought a bunch of loaves of bread and butter and lived on those for days, attempting to save every one of those American dollars they could save. And about the time it came time to leave, I got a message from Moscow. The Soviet Union has been dissolved, and all of your guests no longer have citizenship anywhere. So I had the good news for them to tell them, you are now countryless people, and it's up to you to figure out what to do. So that was quite a shock to them, because they said, oh, at the end of the thing, they said, well, we're going home and we don't know what we're going home to. But it was a good meeting. But that was sort of the atmosphere in our interactions with the Soviets. They built good stuff. They weren't nearly as good engineers as we are. They built some radio telescopes which were very ingenious, but hadn't been planned well, and the prototypes hadn't been developed, and the mechanics hadn't been tested, and so they didn't work very well. And that was typical of everything Russian, by the way, not just in astronomy, but in the homes and the trolleys and the cars and the army. But that was what that was all about. It was all a friendly thing. And when the Soviet Union collapsed, within weeks, the whole scientific empire in the Soviet Union fell apart. The government abandoned it and sort of canceled everything. And so these people were suddenly, when they got back, they weren't out of jobs, but they had their salaries cut, and all the money that might have been given them to build new antennas was canceled. And what happened was a lot of them migrated either to the States or to Europe and took new jobs. And since then, the Soviet Union has remained very weak in radio astronomy, when they had been actually very, very good at it. They still have the antennas they build, such as the Astron, but they used to give good scientific papers at the meetings and all that. That doesn't happen anymore. You hardly even hear of them.
Do you think there was anything special? And why? It's just the U.S. and the USSR that was actively involved in SETI. Is there anything special about those two countries?
Yeah, there was something special. The Soviet Union, the government of the Soviet Union had a very serious goal they pursued, which everybody knew when they told people, and that was, we are going to become the most powerful country in the world. Our army and our military will become the finest, and our science is to become the top science in the world. And for that to happen, we have to be better than the Americans. And they said that quite publicly. And one of them, not Kardashev, but the guy at Leningrad.
Ginsburg?
No.
Kellermann?
Anyway, one of their top scientists told me that that was the attitude that they were getting. A lot of this was before the Soviet Union collapsed. They were getting a lot of support from the Soviet Union. They said, you know, the other day, Mr. Brezhnev came by and visited us because he wanted to see what we were doing, and offered to give us any money we wanted. I said, why? He said, why? Or the Russian said, why? And Brezhnev's response was, well, I understand that the only place in which we are better than the Americans is in SETI. I want to fix that.
Of course, we had the same attitude in the U.S. to be better at everything than Russia. Any other comments on this particular topic from the panel or from the audience?
I could add one
Yeah.
small
Yeah,
thing,
go ahead.
just in regards to what Frank was saying. The book Intelligent Life in the Universe has come up a lot during this conference. And for those of you who don't remember, it's the book that was co-authored by Sagan and Shklovsky in the 60s. Shklovsky actually never was able to get royalties from that book, and he spent most of his life in nearly abject poverty. And Sagan felt so bad about this that Sagan constantly would try to give Shklovsky money. He paid his brother's medical bills when he was in the hospital. So this inequity between Soviet and American scientists, including SETI scientists, was something that was very pervasive during this time.
And let me comment on
The
that.
book actually is a translation of Shklovsky's book.
Somewhat. So Shklovsky did write a book called Vysyelenaya Yizum Razum, which means Universe, Life, Mind, and that was published in 1962. Sagan had wanted to make a translation of the book, but in doing so had annotated it until it about doubled in length. So it's not quite a translation. It's like a one-sided collaboration, and it was all done before they had even met each other. Just
Do you know who
communication.
translated? It wasn't Lynn Margulis who translated it.
I don't know actually who it was specifically.
Yeah, he has a delta sign.
It says in the
Sagan
book.
has a delta sign upon paragraphs that he
Yes.
wrote.
Talk about Shklovsky a little.
Yeah, go ahead.
I knew Shklovsky very well because he did come to the meetings, and I'd see him in international meetings. He was a brilliant guy. He was the person who understood the physics of the synchrotron radiation that turned out to be the main source of radiation for radio astronomers. That was a Shklovsky win. He was very poor. He was also Jewish, and although the Soviets tried to hide it, there was really widespread, mean anti-Semitism in the Soviet Union, right up till today, for that matter. And so he never had much money. And when he came to the States, the first thing he'd say to me, I'd usually pick him up, he'd say, I want to go to a shoe store. Because he said, the shoes in Russia are terrible, but the American shoes are so good. And that's why I come to America.
Can I add something?
Yeah, Tom.
So I thought, you made a remark about this, Ken, earlier, that the Russians had different ideas about how we should communicate and what kind of signals they were. And I thought that was interesting. I remember going to Frank's meeting in Santa Cruz with the Russians and hearing all these very different ideas than and we're not that, we're on the same planet. And so I was thinking, if these two cultures that are on the same planet can't figure out what the way to signal ET is, then probably we've got it wrong. One of the things that was interesting was not only were they thinking about interesting radio stuff, but they were also doing interesting optical SETI programs way before the US was doing optical SETI. We thought about it, and Charlie Towns wrote about it, but the Russians had a 6-meter telescope program, Project Mania, and I worked with a guy named Victor Schwartzman, who I think I met at your meeting in Santa Cruz. And when he went back, he committed suicide because that program, I don't know exactly why he committed suicide, but it was a sad time for the scientists.
Another one committed suicide too when the Soviet Union broke up.
Yeah.
And let's say let me think about it.
There were two other issues with CTA 102. One is, remember that trapezoidal pattern that Rebecca showed? They fit a trapezoid with a period of 102 days, which sounded kind of dicey. But more importantly, as Frank said, Shklovsky was a good astrophysicist. He understood that was physically impossible to have that rapid a variation from a synchrotron source. And it's still, we have some ways out of it now. I mean, it's confirmed. He really did see those variations. And
I don't know what I was going to say is, he didn't come to all the meetings, particularly the meetings in America were difficult. They just wouldn't give him permission to come.
the first time he came to the U.S. was for the Jansky lecture here in Charlottesville in '66. 7 or 8.
Not the Texas
And
symposium?
I asked him, why don't you come? He's a leading Russian scientist, and he was known as Russian.
Even the same.
And this is his response, quote, I'm quoting Shklovsky, because the bastards know that if they ever let me out, I'll never come back.
Ken?
Yes, Jill, go ahead.
If the Soviets had been able to come to the Texas energy meeting, they would have understood the CTA 102 spectrum because of the infrasound self-absorption.
Well, Jill, this isn't the meeting to go into this in detail, but the variability was too fast. And a self-absorbed synchrotron source, if it varies that fast, it has to be so small that inverse Compton radiation would extinguish it in a few hours. But that's not something to go into now. Jason?
Right. But they were impressed by the fact that the spectral shape matched what Kardashev had predicted.
That's correct.
And that's what I was going to say, that in that
That's why they
64
observed it.
Kardashev paper, he discusses what he imagines the radio spectrum of the galaxy filled with transmitters would look like, and that you would have most of the power where the background was low, and that if he inverted the galactic spectrum, he got what he thought looked similar, not quite, and shifted over to CTA 102, and that was one of the main arguments. I also wanted to say, though, that not all of the reception in the United States to this claim is negative. It was quite a cultural phenomenon that alien life had been discovered, and so I encourage you to Google the birds as in band.
I almost put it in my slide.
Who wrote a song that's on one of their albums, To the Aliens of CTA 102, which is a nice pop ditty, but then it transitions to you hearing the song travel through space, and then it ends with this psychedelic discussion between the aliens discussing the bird song that you
Yeah, if I had had another 10 minutes, we could have gone into the cultural impact of CTA 102, which is huge. But I think it's an interesting distinction, I guess, between like public opinion to these things and the scientific establishment, and how you justify those two things.
We don't want to get into too much detail on CTA 102, but I should tell you it was discovered by Dan Harris at Caltech, who was observing other sources with a transit telescope, and he fell asleep, and I think he had a few beers, and the source drifted through the beam, and this new source came up. So he was observing 3C sources, and he just called it CTA 102. My first scientific paper, 1962, was on CTA 102, showed the spectrum. So that's a fascinating source. Yeah.
So I wanted to follow up on a
Rebecca?
Just a minute, Joe, a question here, and I'll come back to you. Go ahead.
I feel bad interrupting Joe.
That's right. Go ahead.
So, to follow up on my question, did you feel there was a philosophical kind of difference in approach to SETI, in addition to the scientific difference between USSR and USA? Or maybe that reflected some cultural differences? I know that there are linguistic differences. For example, the words for SETI in the report that Rebecca showed, would be literally translated as not communication with extraterrestrial intelligence, but connection to extraterrestrial civilizations. So, so there's at least linguistic difference. So basically, bottom line, did you feel there are any philosophical differences in approach to SETI?
I don't want to occupy the whole panel, okay, but yeah. Well, yeah, I mean, there certainly were several, and I could talk endlessly on this, but just to give us maybe a quick example, I think one philosophical difference actually had to do with the engineering prowess of the Soviet Union, in that they didn't really have much compared to the US, and so a lot of their SETI was a lot more, I think, freely imaginative. Shklovsky, for example, highly respected, very eminent astrophysicist, theorist in the USSR, when it came to SETI, really allowed himself to speculate wildly. I think one of the most famous examples is he published in a journal, he had done some predictions about the orbit of Phobos, the moon of Mars, and he thought that because of its unusual orbit, it must be hollow, and if it's hollow, it's therefore must be an extraterrestrial satellite. And so the Soviet Union tended to have a lot more of these kind of what we would consider wild ideas. And actually McNeil, I didn't talk much about it, but the paper that I posted up there was a collection of his notes that were published in the University of Chicago magazine. And in that article, which you should read, he says something along the lines of the Russians seem, deranged compared to the Americans in their ideas. And he uses quotations around a lot of what they say. I think that would be one example of the approach.
That's Jill first. No. Jill?
Yeah, it was just, Rebecca, going back to the Neil, that was the first sort of really tense interaction between the technologist and the social scientist. I wasn't really happy.
Yeah, I think that's true. It's would you say that that's largely because of Carl Sagan's influence?
I wasn't there.
Oh, fair enough, but before your time.
So he brought the group together.
Yeah.
If you read the transcripts of the two Biuricon meetings, I think some overall differences in approach do emerge, and one is actually, I think, summed up in, I forget the name of the academician, but it's the first paper in the first Biuricon proceedings, and he talks about, he starts off by lauding the American colleagues and saying these guys are really smart and they have some great ideas and they've been proceeding on similar lines as we do. However, the problem in the Americans' approach is that they tend to assume that the aliens, or whatever, the ET, will be at a similar evolutionary stage as us. And that's like not likely. And that Soviets, I think in general, were more interested or more open to imagining far future evolution and looking for what Kardashev called type 2, type 3, and sort of, and what Shklovsky called miracles. And I always wondered if that was related to sort of dialectical materialism and the influence of Russian cosmism in the sense that they saw, humans as part of this grand evolutionary direction that had an obvious outcome.
Yeah, we're going to personally talk about Russian philosophy after this. I don't want to steer maybe the conversation back for Seti, but yes, we're going to talk about that.
That was Viktor Ambartsumi.
Yes.
And he was an Armenian, actually, but he was a very senior Russian, Soviet scientist, although he was an Armenian. And he was a politician. I mean, he played the game and didn't step on the toes of any of the dogma and all of that sort of thing. But yeah, that's who you're talking about.
Yeah. Thanks.
Do you have any more, Jason, you want to say? Or?
Not on this topic.
Well, no, let's move on.
Oh, okay.
Go ahead.
On these topics, I suppose. So there's questions here about, what might be the best techniques to detect BTI and so on. And I touched on this a bit in my talk. I wanted to point out, and this came up before in your talk, that there were 4 papers that laid out a thesis on how we should go about looking for extraterrestrial technologies that came out in the span of 5 years. There was Frank's work with Project Ozma and the Cocconi and Morrison paper. There was Charlie Towns' paper on using lasers. There was Freeman Dyson's paper on looking for waste heat, so not for communication at all, but just for an inevitable byproduct of technology, very big technology. And then there was Bracewell's paper that argued that we should be looking for things in the solar system. And for various reasons, the radio approach has had the most work done on it, and I think occupies the biggest part of the popular consciousness about work in SETI. Less well known to the public, but there's been a lot of work in optical work as well, especially with, especially at Harvard. With Freeman Dyson's approach, that also sort of entered the popular consciousness. There was a Star Trek episode about it, but there's been hardly any searches on the topic. I think basically 2 or 3. And then in the solar system, almost nothing. There's been a couple of papers by Freitas, and then there was the notorious Face on Mars incident. And that's just the ideas that came up in the first 5 years. Like, just from those ideas, so when I say not much has been done, I mean in a broad perspective of all the things we could be looking for, not much searching's been done. And since then, there have been many more suggestions for things that we can do. And so to answer one of the other questions about where to look and what can we do in the scope of the effort, there are two approaches you can sort of take to a big problem like this. And one is to guess at what you think the answer is going to be and just push really hard in that direction. And the other is to take a much more basic science approach and just get lots of people thinking about lots of little ideas and seeing where everything goes. And both have a lot of value. And so I think there's, one of the things I really appreciate about what's going on at the Breakthrough Listen Lab is the emphasis on publications and on student training and postdoctoral training, and on making sure that it's embedded within a larger culture of astrophysics, doing work with fast radio bursts, and engaging the radio community and keeping it connected to the academic culture. And that's something that I've also tried to do at Penn State in my small way.
If I follow up with a question to that. So you mentioned it being part of the academic atmosphere, and you mentioned, of course, that there are a lot of ideas, including things that we're doing in Star Trek, and you talked about the bird song with CTA 102. Do you think that science fiction and popular conceptions of SETI are of detriment to academic SETI or in support of? It
definitely cuts both ways. I mean, for sure. I mean, so many people want to get into this because they see the popular imaginings of alien life in the universe, and it's it's feedback. The Dyson sphere appears in Star Trek, and now people see that in Star Trek, and they know it's a thing that you can look for. And so, I think all of us have had to deal with tabloid fodder that comes out of the work that we do. And so that's a negative side. But on the other hand, the tabloid fodder wouldn't sell so many tabloids if it weren't something the public were really, really interested in. And so that also makes it very easy to talk about what we do and to inspire people to go into astronomy.
Scott?
So, first of all, Jason, I just want to say I completely agree with you about the Breakthrough, and I just want to give a big thumbs up to the Breakthrough crew. I think they're doing it the right way, and I think they're fighting a little bit upstream, so to speak. They're swimming against the stream, given the negative vibe in the scientific community that SETI had gotten over the last couple decades. They're doing it right, and I think I certainly am giving them props for that, and I'm enjoying working with them on what they're doing. So I just wanted to say I fully agree with you. But the second thing I was going to ask is about the other types of searches that have gone on. And I know you've done a little bit of the waste heat type searching. And I was wondering, with we're in the era of all sky surveys of various types, and I was wondering what the opinion of the panel is on, are Kardashev type 2 and type 3 civilizations going to be effectively ruled out in the universe in the next 10 years?
I would say, so first of all, I think the all-sky surveys, in some ways, if you wanted to design how would you go looking for anomalies, how would you go looking for all sorts of technosignatures, all-sky surveys are what you would want to do and put them all together to get kind of a panchromatic view of every source in the universe. And that's interesting astrophysically for a lot of reasons. I'm really looking forward to SphereX, which will help with that. And so I agree that's the way to go, and we have the data to do it now. As far as type 2 and type 3 civilizations, the way Kardashev put it, I think that would have been much easier if there weren't so much damn dust in the universe. Dust is very interesting, but it does exactly what a Dyson sphere does. It intercepts starlight and it reprocesses it into the infrared. And so it doesn't do it in exactly the same way. There are a lot of ways to distinguish. But what it means is that when you go looking for all these things, what you find are the dustiest things in the universe. And so, if I'm going to do much more of that, I have to become an expert in starburst galaxies and embedded stars and, far infrared surveys and all of that. So we can put very weak limits on those things, and those weak limits are set by the dustiest things in the universe that haven't been well characterized yet. And so it'll just be a long slog to show that each of them is natural.
Yeah.
I just wanted to amplify.
Jill, just a minute, I'll come to you.
I just wanted to amplify your comment about the popular culture and its positive influence. Remember, at the same time, there were tabloid discussions of these topics. 2001: A Space Odyssey came out, and that was a really deep, thoughtful approach to ideas that von Neumann and others had. That I think they certainly had an influence on me as a young kid, and I think that overall, the sort of intersection of the SETI community with the popular world was a lot bigger than it, and in many ways deeper than it is now. Right? Little Green Men is what we do now, and I certainly appreciated what was happening in the 60s.
Because Jill.
Well, I was just trying to say one part of observational space that we had no sensitivity to until now is transient space. The radio community is now getting into that because of the fast radio work, but we're about to put instruments on the sky that for the first time look at all the sky all the time in optical. And I think it's really an exciting opportunity to begin to be opening up this new parameter space.
Okay, one more.
Hi. You saw me, right?
All right, two more. Go ahead.
Yeah, you know, I taught for many years a graduate and senior level astrobiology class, and at some point in the semester I always discuss the Kardashev scale.
Right.
And I can't think of a more period piece expressive of the Cold War and the view of superpowers than the Kardashev scale. And so one thing that my students never failed to settle on was that this was an exceedingly naive and sort of colonialist view of how a civilization would be rated. And so they would come up with alternative schemes, you know, for their big giant semester-long project and so forth. And usually they centered around, gosh, if you were that smart, you would have learned how to be exquisitely efficient at sustainability. And that sustainability is not big and flashy. And so sustainability might not feed into our Star Wars version of large techno artifacts and so forth. I think technosignatures are probably very valuable, just like biosignatures, but I think we've got a very Cold War hangover view of this, and my students were very tuned into that, and so I think that, you know, some of our ideas about SETI that were developed during that Cold War framework are maybe a bit worn and dusty, and we might want to brush off our thinking caps, so to speak, and revisit some of those issues about what we might be expecting.
We need to move on, then we can come back. Quick, you have a question?
I want to tell a story.
No.
You
You have a quick question? Because we need to move on, and then we can come back.
I'm addressing the question of Dyson's field,
Okay.
and you saw me several times, okay? In 1969, Ed Nye and Nick Wolf built the first mid-infrared photometer, and they measured, follow up a number of the IRC sources, among them NNI-60, Tau, and also later IRC 10216. They saw 300 to 500 degree black bodies. So some of the students to us, they say, well, these are Dyson spheres, okay? Because there are no other natural explanation known at that time. Now we know they are optically thick stellar envelopes. So these things are all over the place. I mean, it would be impossible to tell something is a Dyson sphere when you have this kind of natural phenomenon going on.
There's a lot of distinctions, but I agree not from infrared alone.
Let me move on and get the other panel members.
Last one.
Okay.
Picking up on the 2001 analogy, okay, is that in fact it's not us looking for them. They're the ones in 2001 that had an effect on us. And so, although SETI is a great thing to do, think about inverse SETI. Is anybody really looking for evidence that we've been contacted? Because that's really that's to my mind what really got people really enthused about 2001. It wasn't that we went looking for aliens, it was that aliens came looking for us and influenced us. And I don't see any research I mean, the problem is with them contacting us, it involves us believing in the green men and UFOs and all the rest. But scientifically, is anybody really, you know, taking this thing seriously?
I want to look out for monoliths.
I would say yes, people look at, like, you know, people talk about looking in the genetic code for evidence of manipulation, for instance. There's one. There are serious people looking at that, for instance.
Skew the internet for various signatures, yeah.
Let's move on. Andrew, do you have anything you want to say?
Sure. Well, let's see, Ken gave me wide license to respond to any of these that I like to. So let's see, so I'm going to start with what are the implications of continued failure. I think I fundamentally disagree with the premise of that bullet on your slide, Ken. I don't think that we should characterize what's happened in Seti over the last 60-odd years as continued failure. I would characterize it as continued progress. I think that when we have a graduate student that takes several thousand hours of time on the GBT that the Breakthrough Listen program has contracted for and writes a paper that gets published in the Astrophysical Journal, that's a success. So I think that's continued success. And I think what the implications of that continuing are putting more and more rigorous limits on the presence of intelligent technological.
Well, that was really the question.
Okay.
I mean, maybe failure was the wrong term to use. But
Maybe I just wanted to restate it.
What are the implications of negative results?
Well, I mean, I think that as in any scientific field, I think it spurs us forward. What are the implications of several decades or a decade and a half, whatever it was, of non-detection of gravitational radiation by LIGO? It made their experiment better.
No, it was different. You weren't here yesterday when we talked about SETI was non-falsifiable.
Why
We had a specific prediction of what LIGO should see.
I think it would be great if we made a detection, but we're not in the business of making detections. We're in the business of putting rigorously defined limits on the presence of technologically capable civilizations, and we do that many, many different ways. And we do an experiment, and we try to characterize our uncertainties the best we possibly can, and then we publish a paper.
But you use the example of LIGO. So we had specific predictions about what to expect to see. And you're right, they had to keep improving the sensitivity. Once they reached the sensitivity where they expected to detect something, they did. We don't know at what level.
But you could make the same argument for instance, the top quark or astrobiology in general. So I think Andrew's point is valid, even if his specific example had a specific threshold that was predicted.
And LIGO does a huge amount of waveform matching under the assumption that GR is the correct theory of gravity.
Yes, but if they didn't see it, it would mean that GR wasn't the correct form.
Okay, so I'm going to take my license of having a couple of minutes on the panel to talk about another one of these. Let's see, what is the best technique to detect ETI? Just to maybe push back a little bit on what Jason said. I think there are lots of different ways that we can explore the universe, and I think it's important to keep in mind that from the perspective of SETI, many of those are already being explored in other areas of astrophysics. So, for example, the solar system, back in 1960, we had not explored the solar system at all to the degree that we've explored it now, and now we've sent many spacecraft out into the outer solar system and sent back pictures and radiometry and all kinds of measurements. And so we are, in fact, searching the solar system for signatures of technologies, even though we're not actually saying that in our proposals to funding agencies. Let's see, scope of effort and maybe private versus government funding. I can speak to that a little bit because I'm very involved in the Breakthrough Listen program. I think that there's room for both. That's my opinion. I think sensitivity is a very important metric in astronomy, and I think we want to use big telescopes. We want to use big glass and big metal in the case of radio observatories. But we also want to provide a way for smaller groups, individual PIs with good ideas, be they theoretical or experiment, to follow up on those. And I think there's certainly room for public funding in particular in that area. Maybe I'll give Anna Marie.
Yeah, go ahead.
I want to echo a lot of Andrew's work, actually, both in data science and when it comes to the future approach for SETI. Most people here don't know me. I have a dual background in data science and in economics, and I study communication. I actually came into the SETI field through data science, and just wanted to tell Frank that I grew up under communism, not under the Soviet Union, but in Eastern Europe, and I completely echo everything you said. There are many stories that I know from my parents and so on that indeed that was the state of science in under communism and Romania. Romania. Yeah. And yeah, what is the best technique to detect ETI? Of course, we need all sorts of better and better instruments, but let's not forget data. And that there is a lot of trove, a wealthy trove of existing data that has not been, that only now we are starting to look at it through new techniques that have been developed by the most recent computational advances, let's say in machine learning, in deep learning, in artificial intelligence. And that's probably the paper that you referred to on the discovery of new fast radio bursts. So there is existing data, then there is of course new data coming in that we can again use all these new computational techniques. Let's not forget simulations. There have been, or simulated data, there have been some presentations here about synthetic data. Let's not forget though that communication is not, I think, thinking about definitions and the ambiguity of definitions. There are means of communication and meaning of communication. And when we have different means of communication, we can think about this in different ways about how we use the data, and the means of communication can evolve from biological, let's say, coding into DNA. That Microsoft has projects that is using right now for storing data into DNA, versus deep learning type of communication where we can have algorithms that are starting to communicate with each other and developing their own languages that at some point we might not understand. The meaning of communication, which is another aspect of communication, is quite different, and we interpret it through our cultural, social, economic context, but that might not be very well translated into some universal ways through which we are thinking about communication. So definitely just researching communication as it is when cells communicate, or animals communicate, or humans communicate, or computers communicate. I think that's one area that should be of great interest for the community. And then about private versus government funding, I would like to give the example of the NASA Seti Frontier Development Lab. The NASA Seti Frontier Development Lab is an AI accelerator that happens for 8 weeks every summer at the Seti Institute at NASA Ames, where in the spirit of collaboration that you know, it has been mentioned here by Carl and Catherine and many others. Data scientists and planetary scientists are brought together to work on major questions. And for instance, last year, NASA Seti Frontier Development Lab had 2 teams, actually 3 teams, that were looking at using AI for the discovery of exoplanets, and another one for and another 2 for astrobiology, and one of them was about understanding what is universally possible for life. And another one that was looking at metabolic networks, specifically at that. And the NASA Seti Frontier Development Lab is a partnership. So it's a governmental, private partnership, governmental NGO private partnership, right? So it's at the level of several institutions, because there have been commercial companies that have supported the effort. There is also again, the NASA and the Seti are partners in this. I'd really like to mention again and to stress the idea of interdisciplinarity and how badly I think interdisciplinarity is needed. So in this workshop we are giving talks about astronomy, about exoplanets, and about philosophy. There will be talks about communication, there will be talks maybe about neuroscience and so on. But we are still kind of siloed, right? Because we are giving our own talks about our own work. So it would be really interesting to actually start working together. And that was the example that we had last year, no, 2017, I think, at Decoding Alien, a workshop where we had very short time, just for a couple of days, where we teamed up into teams and we tried to come up with answers to some of these very, very big questions, and to come up with roadmaps. And again, we are talking about interdisciplinary teams that are literally hands-on working on some problem for a few days or maybe a few weeks. So I think that's where probably we should think about how to actually start this collaboration and interdisciplinarity with like really a hands-on approach.
Thank you. Questions for Anne-Maria? Yeah.
I just have a general question, maybe Anne-Maria. But if I look at today, there's significant momentum, I would say, behind SETI, generated by the donation of one individual that part of that saved this telescope. So we're all grateful for that. That one individual could decide to take that away when this is over. So the question is, what's next? What, you know, you're doing this big project. Where do you go next? And is it the funding model? Is that the funding model? Finding the billionaire, and we heard very nice words about billionaires yesterday. But I don't know, and so.
So I can speak to that a little bit, because I can tell you I think about it a lot, personally. The history of SETI has been very cyclic, and there have been a number of very large infusions of money into the field. I think the first came from NASA, actually, with the High Resolution Microwave Survey Program, and that was killed in 1993. And then there was Project Phoenix, where several tens of millions of dollars went into that program over the course of several years. And then that transitioned into the Allen Telescope Array, you know, where more tens of millions went into it. And then, of course, Barney Oliver's estate as well was another tens of millions. But there have been these sort of ups and downs, and now quite clearly we're in an up part. You know, this is a boon time for SETI, but whether or not that's going to last or not, we don't really know. And I think you know, any one individual is not going to, you know, fund something in perpetuity unless there's some sort of endowment or something, which in this case there's not. So, you know, Jason mentioned academia and academic integration, and I think if I were to look back at the last 60 years of SETI and sort of put my finger on one thing that I think could have been done better, it's that. It's integrating with academia more. And in fact, one of our biggest challenges right now is people, is graduate students and postdocs, and finding people that, you know, have an interest and skill in wanting to work on this topic. And I think if SETI is going to be sustained, and again, Jason has talked about this a lot, and I've spoken about it as well, we really need to sort of create an academic environment where SETI is a credible scientific topic. And there's not just sort of one radio telescope in the northern hemisphere and one radio telescope in the southern hemisphere that's doing it, but every telescope has SETI as part of its scientific program, and every data set is being exploited for evidence of technology. We know that the universe gives rise to technology. We're sitting here, we're evidence of that. And so to somehow sort of exclude that from you know, the panoply of things that we do in astronomy is, I think, just tragic, and we shouldn't.
And I would add to that. So I was working with an economist, and Maria can correct me when I get this wrong, but there's apparently a theorem that says that any public good will always be underfunded by purely private sources. That's how I remember it. And so the point is that it requires public investment to appropriately fund the public good, which basic science and SETI is. But the way that happens, for various cultural reasons and institutional inertia, is through our peers who decide what the scientific priorities for American science are. And to a large degree, that's you in this room. And so right now we're going through the decadal process. And, you know, if the decadal process decides that this is a priority for NASA and the NSF, then I think it will be. And what is that process? That's white papers from us, that's endorsements from us, and then it's us as peers sitting on these panels and writing these documents. So there's also a congressional issue, there's also management at NASA, but ultimately it's us. And whether we see it as part of astronomy, whether we teach it to our graduate students, just like we teach other topics that we might not personally work on, whether we tell students that's something they can work on and expect to do.
Can I?
Yes.
So, the NSF has kind of a funny advertising problem in the fact that it's clear that the very first U.S. government agency to support SETI was the NSF, right?
Excuse me, Joe,
Yeah.
I need the black one.
Other Joe.
And,
Not you, yeah, go ahead.
But also the NSF has a sort of a PI-driven thing. So it is true that the decadal support would be very strong for the NSF, right? But the NSF also consciously actually avoids getting too much congressional input, which is a dangerous thing. Good and bad.
I think there's something important here, which is that when Congress eliminated funding for SETI in 1993, it really did have a chilling effect on the community. And I think then you had sort of 25 years since then where SETI was kind of verboten, and a whole sort of generation of astronomers.
Forbidden to be done at the Green Bank.
Well, no, but a whole, technically speaking, perhaps, but I think a whole generation of astronomers and astrophysicists sort of, made their careers sort of in that time. And now I think NSF and NASA has this problem with peer review, and that we sort of put out, our proposals to our peers, and they're sort of already kind of trained to think that SETI is sort of crazy. And so I think it's very difficult to get an impartial panel for SETI research being reviewed, and I think there needs to be some kind of corrective action. So I think this is a time where
it would be very strong. You'd obviously have to work that angle, but that would be.
Go ahead.
One more here.
I think Frank had something.
Okay, I just wanted to correct something. The first, the governmental support for SETI came from NASA. And they supported a limited program which is based at the NASA Ames Research Center. That grew into the microwave survey you've heard about.
Actually, I'm pointing slightly different. I'm saying that the NSF supported the Green Bank doing what they wanted to do. That's what the NSF supported.
Well, yeah. The NSF,
That was the first funding for it. Was the ability of investigators to do what they wanted to do at their sites.
Let's see, first Joe.
I was just going to comment on somewhat the connection to the academic community. The Europa lander was not a community-driven, not a decadal survey-driven project or concept. It was driven very strongly by Congress. As soon as the congressional supporter went away, lost an election, support for that land, the support for the lander within the community was never strong. As soon as this congressional support went away, it dropped. So there's a certain danger in tying oneself too closely, whereas I think Rebecca described this, things that bubble up, they can take a long time. As Catherine described, it can be generational, but they may have a longer staying power than the 2-year turnover dictated by the Constitution.
I think the thing that I want out of Congress is not so much, some sort of line item funding for 20 years, but just to sort of correct the record, just to give it the stamp of approval, and just to say, look, it's okay, here's a little bit of money, it's fine. And I think that communicates not just to funding agencies, but also to the field, to our colleagues, that this is not some sort of kooky thing anymore in the eyes of the U.S. Congress. I think it's not the money, it's the stamp of approval, and I think that's not the only step, but it's sort of an important step in a broader effort to, I think, engender a different view about this.
I agree. There's a misperception in the community that it is illegal to spend federal money on SETI. People think that's true, and that isn't true, but so that would help with that a lot.
in this company here, we should recognize that great big giant thing you see out there, the GBT, was authorized by the government without being recommended by any group of practitioners.
There was a question in the back that's been.
It's kind of similar to this because when I think about the way NASA tries to advertise itself, I mean, there is this sort of intrinsic, that people find space inherently interesting, but they have this very pragmatic approach that they adopt too, like the spin-off stuff. And I mean, I'm not too enmeshed in the Seti advocacy, so maybe I'm just ignorant of this, but it seems like it's very often pitched just as this, hey, we're interested in this question, we want to find this out. But maybe the thing that resonates a little better is, regardless of whether you answer that question, what else do you get from it, right? And would that sort of more practical advocacy have any benefit, or is there information there?
I think you can certainly make that argument. I also think putting too much emphasis on the things you get besides the question you're wanting to get answered can lead to undermining the question in fact. So I think SETI is actually a fantastic example of a science that has led to a lot of development of new technologies that ended up being really useful in different fields, and certainly even discoveries in and of themselves. But I think there's danger in trying to get it funded or promoted by only the things it can get if it does not succeed in what it's trying to do.
Here is that question really as interesting to the public as everyone here thinks it is? I don't know if we can be completely confident that it is, and well, that's the panel tomorrow. But
We've only got about 10 minutes. Before we go to the audience, I'd like to get back to the question of Frank. I think you had something to say about where we should be looking, how we should be looking. You wrote to me.
Oh. Well, I don't have much to say except to say that the way we have been working recently under Andrew's guidance has been the right thing. In SETI, the name of the game is to look at as many places as possible for a sign, for a signal. It's as simple as that. We're not recruiting people or sending money to the universe or encouraging creatures from outer space to land. We are trying to hear a radio signal from another world. And that's the whole game. It's the only legitimate game that SETI has these days. And
Right, that's an argument that it's radio is only.
okay, sorry, an electromagnetic signal. Well, I agree with that because I'm working on optical SETI these days. But we want to find a signal, and we do that in the best and most economic way. We've gained great experience in looking for radio signals, and that's being exploited to the hilt. And so we're doing the right thing, and I think we just continue more.
Actually, I would disagree with you somewhat, Frank. I would say that 50 years on, it's appropriate to be thinking in this broader picture of looking for techno-signatures and thinking of these new instruments that are going to be built with much better capabilities that are going to be looking in interesting directions, sometimes at exoplanets. And we ought to be thinking about what they might detect, what kind of anomalies might come out of these new telescopes that would indicate a technology.
Well, if somebody else can find a SETI signal, that's fine with us.
Right.
Another way of perhaps asking the same question that we've been discussing for about the last 3-4 minutes is with respect to Dyson's first law of SETI investigations, which I had never seen before today. I think it was Kelly who put it up.
I put it up.
Oh, you put it up.
The citation is private communication, Dyson. You sent it to me in an email, but I've decided it needs to be
Well, thank you for putting it up. But does that provide a context for this? I mean, there are some obvious things that are interesting about doing the search better and better and not finding a signal. But are there things that go beyond that, things that either Jill was alluding to or anybody else?
Would you ever do high-resolution microspectroscopy if you followed Dyson's first law? I mean, unless you say that the
You're the
instrument.
radio astronomy.
Well, I don't follow Dyson's first laws.
Remind us what Dyson's first law
So like
is.
Dyson says that you should have interesting results even when you don't find aliens.
Well, I guess I would say that it's an interesting result if we observe, a million nearby stars and don't find any narrowband radio signals down to some particular EIRP over some particular band, and we place that limit. I think that's an interesting result.
And I agree with you. I think this goes back to actually his original paper where he was looking for something that didn't require them to be trying to communicate with us. He was looking for some sort of an inevitable signal, and he wrote in that paper that, if you find bright infrared sources in the sky, those will be interesting in their own right, and that's why you should study them anyway. And so I think this is a personal philosophy of how Freeman Dyson would like to approach the problem. And perhaps it is a critique of other approaches. And so I don't see it as an iron law. It's not being a radio astronomer, and being someone who has who thinks about it, has gone looking for ways. I find it personally as a good guide, but I think of it more broadly because I would not say that, for instance, the Breakthrough Listen radio program has not had anything to say scientifically as a result of its work. I mean, you guys have done work, covered Nature. I mean, the science coming out of the lab is really good, and so I would say that they're following how I choose to interpret Dyson's first law.
I'm surprised this is even being discussed because that's exactly the law I apply to giving projects to graduate students. I mean, all of us should, we give something that you're going to get something, but I've really been trying to say something for a while in observation on the funding. And that is, I feel like the discussion centered around the idea that this is a normal funding enterprise. There should be more work for origin of chloroplasts. There should be more work for that. But this is a totally different animal. This is about as high risk, high payoff as they come, short of saying you're going to look for the incarnate, presence of a god on U.S. soil. And so really, there's no question if I'm successful finding prions in Archaeas, which we probably have, I'm not going to get in the front page of every newspaper. Maybe one of my siblings might notice. Probably not. Maybe my husband would notice. Probably not. If any of you are successful, I mean, for goodness sakes, dead fossil Martians are on the front page of every newspaper in the world. You are in the ultimate field. So really the question is not, how are we ever going to get money? Because if you have any signs of success, you will have more money than you know what to do with. It's how to carry the field until then.
One final question or comment.
Yeah, and actually I'm going to bring it back to the topic of this meeting, of this whole workshop, which is what you're describing, what Freeman Dyson's first law is actually describing is observational science. It's a fishing expedition. You go looking for something, whatever you find is going to be interesting. That's how you catch fish. That's what Barry said. So,
but that's not how you get grants funded.
Unfortunately, in the current environment, that's not how you get grants funded, but that's probably more of a problem with the funding agencies than with the observational sciences.
We have 1 minute for a final.
So on the topic of funding, is there a non-SETI discovery that you think has high potential to significantly increase SETI funding? So like, for example, a biosignature on a planet or a planet around Alpha Centauri. And I'm curious about this question in general, but also in particular with regards to this certain private individual, if you're allowed to say.
What's the question about?
So, do you think that there could be significantly more funding in SETI if there was a non-SETI discovery?
Yeah, so the problem with funding in SETI is I think people have to see this as a credible possibility, but also see intrinsic value in the non-detections. And I think many people do see intrinsic value in the non-detections and understand that we are placing important limits that will guide future work in this field. And so I think most individuals that I work with I think would agree with that statement.
It comes down to somewhat the culture of science now, and scientific establishments and institutions not rewarding false results or negative results, which are, like you said, intrinsically valuable. But the way that the disciplines are going is not to reward investigating things that don't come up with positive results, because that won't get published in a journal, and we need journal publications in order to get tenure, et cetera, et cetera, et cetera. So it's also, I think, a cultural issue.
Okay, I think it's a good topic to continue up in the Drake Lounge. Jason, I don't know if you're aware that the bird song was actually referred to in a peer-reviewed FJ journal. It's cited.
All right.
I couldn't find it.
Are you gonna play it?
Yes, I've dug it up here.
It's not a good song.
It was referred to.
So you got that from a link to the journal? Is that,
Skip to the end of the alien stuff. I think. Aliens talking about.
well, let's say, yeah.